Earth's history. The Earth's surface has gone through a lot of changes. How do we know this? How do we know this? How do we know this?
We have plate tectonics, which means we have earthquakes and volcanoes and weathering and erosion.
All of those change the Earth's surface. And if all of those change the Earth's surface right now, it had to have happened back then. That's the James Hutton principle called uniformitarianism. Dang, that's a long word. All it means is that the present is the key to the past. And if a process on Earth is taking place right now, it had to have happened back then. Because plate tectonics isn't something new. It's always been going on.
Same thing with earthquakes and volcanoes and weathering and erosion.
And remember, we know that this stuff occurs. We know that plate tectonics takes place. We can measure it with lasers to within centimeters per year. That's pretty darn accurate. So all of these processes that happen today, the earthquakes, the volcanoes, weathering and erosion, we can track all that stuff that's happening now, so we know what happened back then. Understanding those processes today means that we can understand more what was going on back before anybody was around. It also helps us understand how fossils are formed and what may happen to them if they disappear or maybe they're only half there. All right, some things we know about Earth's history. The Earth is old. I mean really old. 4.56 billion years old. We know that Earth now wasn't the same as Earth then.
And when I say then, I mean a long time ago, like billions of years ago.
The processes going on today are the same that was happening then, like the earthquakes and the volcanoes, that kind of thing. We know life now is not the same as life back then. And we also know the atmosphere now is not the same as it was back then. The very early atmosphere didn't have any oxygen. That means it didn't have breathable oxygen and it didn't have ozone, which is an O3 molecule. Really hard for animals to live on land if there's no ozone layer. But roughly about 3.9 billion years ago, changes started happening and there were some organisms that had developed. Those were called stromatolites. And they produced photosynthesis, which gave us the oxygen in the atmosphere. Also, volcanism helped produce oxygen in the atmosphere too, because when volcanoes go off, they produce a lot of gases, and they put a lot of gases in the atmosphere. That really put enough in there so that we can get those O3 molecules and make an ozone layer. Once there's an ozone layer, life on land was possible. And now you're going to ask me, how do they all know this stuff? By studying the fossil record. Let's look at the geological timescale.
It is divided up between 4 eras, 12 periods, and 7 epochs. The Precambrian, which is 88% of geologic time, has the oldest known life, and there's not many fossils in that time. The Paleozoic has life in the oceans. The Mesozoic is the age of the dinosaurs, and the Cenozoic is our current era, which contains horses, pigs, bears, and of course, humans. We are in the Quaternary period in the Cenozoic era.
Now, I said the Earth is old, and it's really hard to appreciate just how old the Earth is. It's kind of hard to teach because, well, it's a lot of time involved. Understanding the scale of time is so important to understanding the Earth's history. Now let's kind of look at a way to maybe appreciate just how old the Earth is, and to really think about just how long humans have been here, which hasn't been that long when you look at it in terms of the Earth's history. Humans are just little babies. I got some toilet paper right here. I'm going to use it to demonstrate what goes on in Earth's history, and hopefully it'll give you a better understanding of just the time involved with everything, all the eras, all the periods. Now, in the beginning, when the Earth was formed 4.56 billion years ago, that's what they call the Hadean Eon. That was the rockless eon. The Earth is newly formed, and it's starting to harden into a rock planet. That was 4.56 billion years ago. The oldest known rocks occur roughly 3.8 billion years ago. And that doesn't mean that there isn't older rocks than that. It just means that's the only ones that we can find. A lot of rocks could have weathering and erosion take place and we never knew that they existed. Or they still could be buried deep into the earth. The Precambrian comprises about 88% of all of the geologic time. That's a lot of time. A lot was going on then. And it does contain the oldest known life. But the Earth has all the time it needs. It takes a really long time to get life started. Let's look at it in terms of my toilet paper roll. This whole roll of toilet papers can represent all of Earth's history up until, well, right now. You can see that I drew a circle close to the inner part. And we're going to go from the outer part to the inner part. So the outer part is 4.56 billion years ago. The inner part is today. So we're that cardboard is, that's today. You notice some things with it, right? 88% of it is the Precambrian times. You got your oldest known rocks and your oldest known life, those stromatolites. That green circle starts the eras of the Paleozoic, the Mesozoic, and the current one, the Cenozoic. So back to our toilet paper. Let's have some geologic history take place. We are now in the Precambrian times. There is lots going on. The Earth's atmosphere is trying to form into what we're used to it today. We're trying to get some oxygen going. We're trying to get an ozone layer so that way any life that does develop can stay on land. And lots of stuff just going on. The Earth is spinning and it is taking care of business. Let's get some geologic time taking place.
It's really amazing. So loose rocks right now. Still nothing going on. The organisms yet. I have such a big toilet paper roll.
I think we're finally at a good spot to say that, well, no, still more history needs to take place. The first known organisms. But we're still in the Precambrian times. So those stromatolites are getting going. There's still been lots of volcanism, lots of earthquakes, plate tectonics are taking place. And there's organisms and the volcanism trying to form a more suitable atmosphere. Because we got to get that done before we get to that line. That line is the Paleozoic times. We did it. Check this out. The Precambrian. Don't worry, I'll recycle it. Paleozoic times. Now, eras stop and start for two different reasons. They can stop if there's a mass extinction or there's a major change in organism. And that's the difference between the Precambrian and the Paleozoic. In the Paleozoic times, you have 7 periods, or maybe 6, depending on how you look at 2 of them. Some books divide the Carboniferous period into the Mississippian and Pennsylvanian. Both are just fine, because in some areas of the world, the Carboniferous is pretty much the same throughout. In other locations, there's a real distinction between what goes on in the beginning of the Carboniferous and the end of the Carboniferous. Hence why some books divide it. Now that organisms are more developed, there's a lot of life in the oceans. At the start of the Paleozoic, about 542 million years ago, that's the period they call the Cambrian, and the life was in the oceans. About 488 million years ago, during the Ordovician, there was a lot of life like brachiopods and trilobites. If you live in the Kansas City area, a lot of the rock outcroppings that you see, especially along highways, you can see a lot of fossils, the trilobite. Flashing forward about 416 million years ago in the Silurian period, that's what they consider the age of the fishes. Lots of fish. During the Carboniferous time period, a lot of coal was being deposited, the coal we use today. When you break up the Carboniferous period into the Mississippian and the Pennsylvanian, the Mississippian has a lot of limestone. Pennsylvanian is where a lot of the coal is deposited, the coal we use today. During the Paleozoic, there's a lot of plant life too. Insects took to the air during this era as well. The climate was pretty mild, a lot of glaciers were melting, and some trees were being formed as well. At the end of the Paleozoic times, about 251 million years ago, there was a mass extinction. Like 75% of amphibians and plants died. 90 to 95% of the marine life died too. They think it was from a major change in the climate at that time. But because there was a mass extinction that ended the Paleozoic and started the Mesozoic, the animals that seemed to survive the Paleozoic were more reptile-like. Started off small, because they were just getting going, but they ended up surviving that change in the climate. Back to our toilet paper roll. Remember that green line was the start of the Paleozoic. And so we have the Paleozoic, and we have the Mesozoic, and we have the Cenozoic. It's all contained right here. So we can start rolling through again. That gets us to the Paleozoic. Now the Mesozoic. The Mesozoic is the age of the dinosaurs. The dinosaurs are reptiles, and they were very small to start out. There was 3 periods during that time: the Triassic, the Jurassic, and the Cretaceous. Now everybody knows about the movie Jurassic Park. The animals depicted in Jurassic Park didn't actually live until the Cretaceous period. Cretaceous Park for a movie name? That would have sucked. Hence why they used Jurassic. There was a lot of continental movement going on starting in the Paleozoic and moving through the Mesozoic. You're probably familiar with Pangaea, and during the Mesozoic, the Pangaea was there. In the Paleozoic times, you have Laurasia and Gondwanaland, forming into, eventually, Pangaea as one big landmass during the Mesozoic time. So you can see how the climate was changing. Moving around land masses like that, of course it's taking millions of years for it to occur, changes the climate. When you get them all together as one big mass called Pangaea, the climate was much warmer then. If you've got all of your landmass in one area, it really heats up. Once they start to separate, things will start to cool off. During the Mesozoic times, as these dinosaurs are getting much larger, there's other creatures as well. You still have a little bit of amphibians, there's still a little bit of ocean life, and you also have small mouse-like mammals taking place. Mammals had to stay small. If you got any bigger, it was really easy to eat them. So because there was large dinosaurs, there was small mammals. Lots of birds, most especially in the later part of it during the Cretaceous period. The first flowering plants appear in the Cretaceous period. And by the time you get to the end of the Cretaceous, dinosaurs are large. The really large dinosaurs that you see all the time, and every kid loved dinosaurs. Those really large animals like the T-Rex and the Brontosaurus, those occurred during the Cretaceous period.
Good time moving again. Let's get through the Mesozoic.
So we started this really big, huge toilet paper, and now we're down to the end of the Mesozoic, the beginning of the Cenozoic time. The Cenozoic, remember, is the current era that we're in today. And because we're in a current era that's not called the Mesozoic, something had to happen between the Mesozoic and the Cenozoic. Roughly 65 million years ago, the dinosaurs died. One large mass extinction ends an era and starts a new one. Now there's a lot of theories as to why the dinosaurs died. The main one is a big asteroid, a very extremely large one, made it through the Earth's atmosphere and crashed on the Earth. And when it did that, it kicked up lots of dust and debris, and it ended up causing what they call a nuclear winter. Reptiles like it hot, so you cool the climate down, that's not going to work for them too much. Plus, with Pangaea starting to break apart as well, you have the recipe for a much cooler climate. Now, once these large dinosaurs died, because reptiles still exist today, so all the reptiles didn't die off, but all these big, large dinosaurs did, which is good, because if they didn't, obviously, life as we know it would never have taken place. So a mass extinction took place, it ended the Mesozoic and started the Cenozoic times. Plate movement is still taking place, Pangaea is breaking apart, and the climate's starting to cool down a bit. We get some ice ages during the Cenozoic times, and it's considered the age of mammals. Those little small mouse-like mammals in the Mesozoic survived that major climate change, and they started to thrive. So modern day birds, you start to get horses, bears, and of course, humans. Now the Cenozoic is divided into 2 periods, the Tertiary and the Quaternary. We are in the Quaternary period right now. That contains the humans, us. Still a lot of tectonic activity going on, still a lot of plate movement, earthquakes, volcanism, all the stuff to change the Earth's surface. Let's go back to our toilet paper. So we're in the Cenozoic times. Let's get to today. And so I can show you on here where humans are. The Cenozoic was just a small amount of time compared to the whole Earth's history. See if I can tear it off without ripping it. Too bad. We are now at the end of the toilet paper roll. Humans are barely on this thing. Humans were barely in Earth's history. Barely there. So crazy to think about. So much time took place, 4.56 billion years, and we're barely a blip on the Earth's history.
We're super tiny babies.
The Earth's history. I really hope you appreciate and understand the vast time that took place. It really is amazing and humbling to think about how much time has taken place for the Earth to get to where, well, we know it today. So try to remember to take care of it, because it takes a really long time to build another Earth.